Hi, okay, today we're going to look at Module 1, Lesson 13, from ratio tables to equations using the value of a ratio. Well, we already know what ratio tables are, and we know that in a ratio table, all the ratios are equivalent because they have the same value. Well, today we're going to use that and learn how to do something called writing equations. What's an example of an equation? Think all the way back to like first grade, maybe even kindergarten. Okay, what's an equation?
3 plus 5 equals...
3 plus 5 equals 8. That's an equation. It has an equal sign, so that's an equation. Today we're going to write equations using our ratio tables. Okay, that's the focus of today's lesson. Let me move this out of the way. Okay, so right now on your tables, I'm going to pause the recording to give you some directions. Okay, George is mixing a special shade of orange paint. I guess getting ready for Halloween. I don't know why else we want orange. But anyway, he mixed 1 gallon of red paint with 3 gallons of yellow paint. So what is the ratio here? Let's start from the beginning. What's the gist? What are the two things being compared?
A gallon of red paint and 3 gallons of yellow paint.
So we're comparing red to yellow, and the ratio is 1 to 3. So using the paint chips on your table, draw a tape diagram. There's enough for 2 sets at each table. So working with the person next to you, use the paint chips to draw a ratio table that shows 1 red for every 3 yellow. So now we're looking at 1 gallon of red and 3 gallons of yellow. So when I mix them to make orange, how many gallons of orange am I going to have?
You're going to have 4
gallons, right. So in this 4-gallon bucket, is it true or false that 3/4 of this 4-gallon mix will be yellow? So in a moment, if you think the answer is true, you're going to give me a thumbs up. If you think the answer is false, you're going to give me a thumbs down. If you have no idea and you're not sure, you're going to give me thumbs in the middle. So on the count of 3, you're going to vote. I'm going to read it again. So here I have a 4-gallon jug of orange. Yes, 4 gallons. 1 gallon of red, 1 gallon of yellow, 1 gallon of yellow, 1 gallon of yellow. In this 4-gallon mix, is 3/4 of it yellow? Ready, set, vote. Well, let's see. Some of you are chicken and waited for everybody else. Don't be chicken. Take a chance. You've got nothing to lose. If you're wrong, you know what happens? I explain it. That's a good thing. So 3/4 are yellow. So this statement is true. So go ahead and write true in your notes next to the first bullet. Now the next one, let's talk about it a little bit. For every 1 gallon of yellow paint, it requires 1/3. Listen, I don't need 4 gallons of orange paint. That's a lot of orange paint. I don't need that much. So instead of using 3 gallons of yellow, I'm only going to use 1 gallon of yellow. So I took this and I put it here. Don't need that, don't need that. So basically I took my 3 gallons and I'm separating it. So now I have to take my red and separate it. So I would have to take this red here and separate it somehow, 1/3, 1/4. But how would I have to separate it so that it would fit evenly in the 3 yellows? Because I don't need all 3. So I would have to separate this into how many sections? So then I could take this would fit here. So that would be 1. That would fit there. 2. That would fit there. And 3. So is this true or false? That for every 1 gallon of yellow, we get 1/3 of red. Ready, set, vote. That is true. So you can write that down. See, it would be 3 to 1. But we don't need all 3. We just need 1. So 1 to 3. I know, that's fun. It's fun to do. All right, for the next one. For every 1 gallon of of red paint requires 3 gallons of yellow paint. True or false? Look at your tape diagram. Use your paint chips in front of you if you have to. Ready, set, vote. Yes, that is true. You can see that in the picture there. There is 1 gallon of red paint and a 4-gallon mix of orange paint. Is that true or false? Look at your paint chips in front of you. There's 1 gallon of red in this big 4-gallon mix of orange. Ready, set, vote. Here's my 4 gallons that made orange. Is one of them red? So that is true. I see a pattern forming here. So now let's scroll down to the last one. There are 2 gallons of yellow paint in an 8-gallon mix of orange paint. So now we're looking at 8 gallons. So if this is a total of 8, what would my constant be in this tape diagram? What would each box have to be worth to make a total of 8 gallons? 2. So my constant would have to be 2. So I have 2 red, then I have 2, 4, 6 yellow. If you don't like looking at it that way, you can look at it this way. There's my 4 to 1. There's my 3 to 1 and my 3 to 1. So is it true or false that there are 2 gallons of yellow paint in this 8-gallon mix? Ready, set, vote. Finally, we got a false one. So write that in your notes. Okay, so turn your note page over, and hopefully you put the date on top of 51. The top of 51 should have today's date. Now on page 52, here's a ratio table to help us with what we just did. So we were looking at the ratio of red to yellow, 1 to 3. So fill in the first 2 columns of that ratio table. Fill in the first 2 columns. Go ahead. First 2 columns. Scale up, scale down. Think of the value. Think of the ratio. Think of the tape diagrams that we used, the paint chips. Yep. So we have, for every 1 gallon of red, we had 3 gallons of yellow. The last question, if I had 2 gallons of red, down here, how many yellows did I have? 6. So I had my 2 red, whoops, never mind, we'll come back and do that in a minute. So if I had 9 gallons of yellow, that was 3 gallons of red. 4 gallons of red would need 12 yellow. 5 gallons of red would need 15 yellows. So how did I get the 6? I took the 2 reds and multiplied it by 3 because that was in my ratio. To get to 12, I took my 4 gallons of red and multiplied it by 3 because that was my ratio, my value. I got to the 15 because I took the 5 red and multiplied it by 3. So what was my pattern? What was my repeated multiplication?
3.
Yep. Times 3, times 3, times 3, times 3, times 3. So whenever I had the red paint, I multiplied it by 3 and got my yellow paint. We'll check in. How are we doing so far? All right. Instead of saying this over and over and over again, is there a way that I could summarize this in like an equation? What did I do? What did I do here? What did I do? Give me an equation.
You multiply the red paint and get the yellow paint.
So I did red times 3 equals yellow. Write that either next to your table, up kind of high, or below your table. I would write this up kind of high next to your table, like up here. I would write that over there. So over here, you could write it. I'm going to write it down here so that I have more room. That's like, what? Yeah, yep. Always multiplying by 3. 3 is my constant. Now, because that's my value, 1 to 3, 1/3. So now, that's like a lot of letters, and I don't want to like keep writing that all the time. Is there a way, what do you think, can I abbreviate that somehow? What can I use? Instead of red, what can I use instead? What do you want to use? Take a guess. Yeah, but I wouldn't know what that means. What would be a better idea? Just use R. So R times 3 equals Y. Anybody confused where the R came from or the Y came from? Just give me a headache because now there's an X in there. I've got an R, I've got an X, I've got a Y. Extra letters. What does X stand for? I know the R is red paint. The Y is yellow paint. Is the X for extra special paint? I don't understand. I want to use the X. The X is confusing me. What else can I use instead of the X? What can I use? What can I use? I could use a dot. We talked about that. R dot 3 equals Y. Because multiplication is very special. Multiplication, you can use the X. You can use the dot. Did you know that you can even use parentheses? That even parentheses means multiplication? I know, it's true. But this is so extra special. Extra special. Multiplication is so extra special that you don't even need to use a symbol. It's true. I know, but it's true. It's true. Did you know that you could just write 3R? Actually, I'm going to change colors. You can write 3R equals Y. And that, boys and girls, is the focus of today's lesson. That is the equation that represents that table. But there's more. I'm not done yet. The number always comes first. That number actually has a name. That number is actually called a coefficient. The coefficient, think of it, cooperates, a co-worker, a co-teacher. So they work together. So whenever you see a number next to a letter without a symbol, you know that it means to multiply. Does anybody know what the letter is called? Don't say R. No, that's in fractions. But thank you for trying. I appreciate it. Now, I'll give you a hint. Starts with the letter V. Starts with the letter V. Variable. So label that, please, because those are important words. So that is your equation. 3R equals Y. 3 is your coefficient. Now, operations. Multiplication. Put that down, please. Hold on. Oh, thank you. You're holding that up. You have that ticket? You have the pink ticket for that? Does it say Y equals 3R? Y equals 3R. You may see capital letters throughout the module. Traditionally, I've always been taught that they're lowercase letters. Your parents always saw lowercase letters, but now we're seeing them written in uppercase letters. So don't be confused if they're upper or lower. Now, this means the same thing, because if it's equal this way, it's equal that way. But what I was actually going to say is this. What property can we say about multiplication? 2 times 3 is 6. 3 times 2 is 6. When order doesn't matter, what is that called? Right, community property. When I leave my house in Sound Beach and I commute to work at Great Hollow, it's 13 miles. Then when I turn around from Great Hollow and I commute back home to Sound Beach, it's still 13 miles. So the distance is the same. It doesn't matter the order. All right. However, even though multiplication is commuted, guess what? When you're writing your equation, you're not allowed. The coefficient always comes first. What did I say? The coefficient always comes first. But Mrs. Lebowski, on my main module assessment next week, if I write R3 equals Y, are you going to take off points? Yes, because technically this is the more right way. This is the righter way. All right, it's the righter way. The coefficient comes first, so there. That's it. Deal with it. But now, that tells me how to find out the yellow. Suppose I wanted to find out the red. Let's look at our table. What did we do to the yellow? What did we do to the yellow to get to red? What did I do? What was my repeated? What did I do? Hold on. Somebody's holding up their pink card. They think they have the answer. But let's see. Oh, I got two people holding up cards. Let's see. First, what do I keep doing to the yellow? How do I get from 3 to 1? Everybody? Divide by 3. 6 to 2. Divide by 3. 9 to 3. Divide by 3. But we're not going to write this like division. All right, you ready? Who remembers what we said? Instead of writing divided by 3, what's the other way that we could write that? That means the same thing. What means the same thing as dividing by 3? Oh, you're going to knock my socks off. Who knows this? What do you think? Take a chance. Got nothing to lose. Try it. No, because that means multiplication. What's another way of writing divide? But thank you for trying. I appreciate it. I could multiply by 1/3. Those mean the same thing, because really, aren't I taking 1/3 of yellow? What's 1/3 of 3? What's 1/3 of 6? What's 1/3 of 9? So another way that I could write this is 1/3 of the yellow equals the red. Remember, we did that on the first page with the tape diagrams. Ladies, you writing this in your notes? This is another way to write the equation. This is exactly what we did here. 1/3, right? 1/3 of the yellow equaled red. So 1/3 of the yellow equals red. Did everybody write those both equations down? I love some of the highlighting that I see going on here. You can write it next to it if you want. All right. All right, we lost a couple minutes because of the fire drill, but let's see if we can get one more done before the bell rings. So if the ratio we said was 1 to 3, suppose we've changed it from red to yellow, 1 to 4. Who has the card for that equation? If it was 4 yellow for every 1 red, who has that card? How can we write that equation? No, we're just talking about it. So what would we do? We would have to take our reds, and what would we have to do? Multiply it by 4, and then we would get our yellow. Or take our yellow, multiply it by a 4th, and then we would get our reds. Suppose the ratio of red to yellow was 1 to 7. You think you have it? What have you got?
R equals 1/7 Y.
Okay, so red equals 1/7 of the yellow. Well done. Who has the other card? There is another one. What do I have to do to my to my red to equal yellow? What do I have to do to my red to equal my yellow?
Divide If I want them,
No. Nope. If I have one red, how do I get 7 yellows? Right. So those, somebody has those cards. Check your cards. Somebody has them. Good. Very good. So very quickly, let's fill in this table for purple paints. Okay, so here's the ratio for purple paint, ladies. We're at the bottom of page 52. So at the bottom of the page, the ratio, now be careful, here it says red to blue is 4 to 1. But look at how our table is set up. 1 to 4. So 2 to 8, 3 to 12, 4 to 16, 5 to 20. So that would make total gallons of paint, because we don't want more than 25 gallons of purple according to the problem. So quickly fill in your, somebody sees their equation already. Someone's holding up their card. What did I do to blue to equal red? Blue times 4 equals red. So how can we write that? Blue times 4 equals red. I find it really helps if you label the top of the table. Blue times 4 equals red. What do I have to do to red to get to blue? What do I have to do to the red to get to the blue? I don't need all of that red. I need less of the red. So less would mean a fraction. What fraction? 1/4. So 1/4 of the red equals blue. 1/4 of 20 is 5. Is that your card?
mine's just reversed.
Does it say B equals 1/4 red? Let me see. Red equals, nope, that's written backwards. That's a trigger one. That's a trigger one. So you have to be careful. Yes.
Are you just adding like 1 plus 4 equals 5?
For the total, yes. And we're going to look at total more tomorrow. Now, it really helps if you look at your heading and say to yourself, what am I doing? Okay? So your two equations here are 4 times blue equals red. 1/4 times red equals blue. Those are your two equations for that table.
And you get the 1/4 red plus 4 blue.
Because if I took 1/4 of this red, because I have to take my red and break it into smaller groups. I don't need the whole thing. I'm making a smaller batch. I need, well, not necessarily, but, okay. So your homework tonight is your exit ticket for lesson 13. Look on your, wait. On your exit ticket, there are 3 different tasks that you need to complete. In order to get a 2 out of 2 on your homework tonight, you must complete all 3 tasks.